Hello, everyone. Good morning, good afternoon, or good evening, depending on where in the world you're joining us from today. A few housekeeping items before we get started. All of our attendees are on mute, but we still like to keep our webinars as interactive as possible. If you have any questions throughout the webinar, please enter them in the questions section of the GoToWebinar panel, and we'll try and answer them as they come in. We'll also be closing the webinar with a live Q&A. So with that, let's go ahead and get started. So thanks so much for joining us for the 3 keys for automating IT management successfully. I'm Kyle Banaz, Director of Marketing at Netreo, and I'll be your host today. As mentioned, please send any and all questions and I'll make sure we get them answered for you. I'm joined today by James Mancini, Netreo co-founder and principal solution architect. James, thanks for joining me today. I'm excited to hear what you have to share with us, considering alert deluge is one of the most common challenges we hear about in speaking with IT teams, and automation is also a challenge, so really excited to get things started.
Thanks, Kyle. So some of the most common challenges we hear about from customers are things that are going to be familiar to many of you. Things in IT have always changed rapidly, but it's only picking up speed. The explosion of things like DevOps and cloud-centric architectures and on-demand dynamic provisioning is making it increasingly difficult to keep monitoring and management tools in sync with the environment. And this leads to the second issue. Management and individual teams often lack visibility into the whole environment. A lot of existing management tools are slow to adapt to the rapid changes and deployments that are becoming routine in most organizations. And we find this is often because visibility suffers when it's difficult and labor intensive to manage. If a manual process is required to add monitoring onto new systems, there's just no way it can stay up to date. Now, often, this lack of an up-to-date view across the organization leads teams to implement their own point solutions. But the more point solutions you're dealing with, the more likely they are to contradict each other, to say nothing of the increased admin and training burden and the communications issues that this causes. Many large customers have told us about the challenges caused when one failure causes multiple alerts from different products to go to different teams, who then argue over what the actual problem is, and that drags out resolution times. Fortunately, most of these challenges can be solved the same way, with automation. We need a way to keep up with the rapid and dynamically changing environment while maintaining visibility, avoiding blind spots, and keeping up on our service level agreements. And all of this while not creating additional administrative overhead that nobody has time for. So automation is something that we at Netreo have been helping customers with for many years, and we define automation maturity in 4 main stages: discovery, monitoring, response, and artificial intelligence. And over the last 21 years of development, our platform has evolved to do all of these. So let's take a look at each of them, and then you can start to see where your organization might be today and what it might take to get you to the next level. So the first stage of automation is really discovery automation. And this technology has been around in its most basic form forever. We've all used tools that do a ping sweep or a port scan to find devices on the network. And that technology still makes sense in a lot of environments, but it's not the whole answer anymore. Because today, auto discovery has changed a lot. There's a lot of things you can't scan for, like isolated virtual systems, things in DMZs, cloud systems, and microservices, just to name a few. Modern systems have to leverage the power of things like API integrations to be able to make automated discovery faster, more reliable, and much more complete without creating network traffic problems. For example, our approach is to leverage APIs to learn directly from things like your CMDB or vCenter, as well as cloud providers like Azure, AWS, or Google Cloud, and things like SD-WAN orchestrators to find those devices, or even cloud-hosted wireless access point controllers like Meraki, for example. And we provide inbound API calls as well to allow users to link the system with existing workflows like Ansible or automations, or to create custom integrations easily. Now, the second stage is monitoring automation, and this is where adding new devices into monitoring and getting them correctly configured no longer requires manual intervention. And for many organizations we speak to, they haven't even really gotten this far yet. And there's a few reasons for that, but one of the most common is that a lot of monitoring platforms are surprisingly underdeveloped in this area, and in-house development resources are scarce and expensive when they exist at all. So to really reach this stage effectively, the management platform must be able to identify new systems not just at the OS level, but also detect things like which services or applications are running on them in order to make the right decisions about what exactly you need monitored on that system. For example, if I bring up a SQL server as a virtual machine, it should enable monitoring of the operating system, the virtualization stack, the SQL application itself, appropriate event log monitors, and who to alert when it has a problem. And that might be different depending on whether it's a SQL problem versus an OS problem. And also things like what kind of performance metrics and statistics that we need to be watching on it. But it also has to include doing things like putting it in the right category sites and business workflows and all of the other groupings that drive reporting and dashboards so that newly deployed systems always show up in the right places and nothing falls through the cracks. And this stage is really about reducing the administrative time required to keep everything operational and to make sure that you're not struggling with blind spots or spending too much time on the care and feeding of a monitoring platform, or in worst case, many different platforms. The third stage is response automation. And this enables your management platform to take independent action to remediate a problem before the NOC or the engineers have to do anything. And in order to effectively automate response this way, we have to allow different actions based on things like time of day or day of week, in case you want a different response during business hours, for example. One of our customers had a application that only needed to be up during the regular office hours. And so if it had a problem after hours, they would automate the reboot of that process. But during business hours, they just needed to notify the NOC. So they also have to allow for things like dependencies, like taking different actions if there are other servers running the same application that are having a problem at the same time. And of course, there needs to be the ability to do this across any platform. So whether it's routers, Windows, Linux switches, or even cloud hosting providers, we need different methods of interaction with those devices, as some are going to require things like API calls, others might need SSH or PowerShell commands, or even Telnet if we're dealing with legacy systems. Now, this can be a big step. And a lot of organizations are going to insist on operator intervention to approve the action before it's taken. And we refer to this as the click to reboot button. And this is a good idea for drastic actions, but it also lets organizations get comfortable with the process and validate their configurations before fully automating response. And our platform supports doing this either way, so it allows for that migration. Now, the fourth stage is things we're talking about artificial intelligence, and there's a lot of different definitions around what exactly constitutes AI. So here we're using the term to define systems that can expand the context and template provided by human intelligence into large-scale data analysis and be adaptive by learning and improving over time. So applying this technology to your operations is typically referred to as AI ops. And for example, the system could look at the alerts coming out of the monitoring platform and detect that a certain kind of alarm is happening too frequently and is likely a false alarm, and then suppress those alarms or modify the settings to stop them from happening. Or it might notice a correlation between specific log messages and a later application failure and restart some services automatically to remediate the issue, since that's what worked last time the application failure happened. Ideally, an AI-enabled management system will make these connections and potentially take actions based on learning your environment, as well as best practice and scenarios encountered across other customers. Again, it's critical to be able to decide which actions to allow to happen completely automatically and which ones require operator intervention, especially at first. So the first key to automating your IT management is to make sure you're taking full advantage of things like discovery and monitoring automation. And obviously the first step here is to use auto discovery tools to make sure that your new devices are adding into monitoring as they're provisioned in the environment. So once the devices are identified, we need to make sure we're getting full monitoring automation on them as well. So we want to make sure we're identifying all the different applications or services that we need to monitor on those systems. And if the configuration is based on something like cascading templates, which is the approach that we take, that makes this a lot easier, as you can have multiple templates applying to a device or application as appropriate. So when we talk about getting discovery working, what do we mean? Our approach to this takes three parallel paths so that nothing gets missed. Of course, there's configurable subnet scanning so that we can quickly identify new systems as they're provisioned or brought up on the network. But as I said earlier, this method has a lot of limitations in modern IT architectures. So we also want to make sure we're leveraging other discovery methods that provide faster and more detailed information, like leveraging API connectivity to multiple vendor platforms. For example, to be able to find new Meraki edge routers as we bring them online, or instantly start monitoring new cloud containers or serverless databases or virtual machines as they're brought up. Using those open inbound APIs as well can help with system provisioning. So if you're using deployment automation tools like Ansible or other kinds of scripted automations, you can easily link your monitoring into that process so that it's not a manual step. And by using all of these methods together, we make sure nothing gets missed, even if things are changing dynamically and even if someone didn't follow the process checklist as precisely as they should have. Now, to get this to the next stage, We need to take that discovered device data and make sure it's getting fully provisioned. I mean, it's useful if a new system gets detected and added into monitoring, but it falls short of getting full visibility if we're not also watching the critical applications and services, or if we're not automatically sending notifications to the right team when something isn't working right. So our approach to solving this problem is using a feature we call auto configuration. And auto configuration comes with a set of rules to help you get started, and you can easily customize or create new rules to fit your environment. But what these rules do is they set device attributes like categories or sites or business workflows based on learned device criteria. Things like what processes are running, what ports are open, what the device is named, or even SNMP values. And this makes sure that there's no manual provisioning process to make sure the devices end up in the right reports and they always get the right settings applied. And these are automatically applied to devices as they're discovered, regardless of what method is used to add them in or what platform they're running on. And we can also make sure that these are reapplied automatically or as needed. So if you want to make sure everything stays configured according to the rules, you can enforce that. And by being rule-based, it means we can manage large environments programmatically instead of manually. And that enables scaling to much larger environments without adding a lot of overhead. To really close the loop on that automation, once the attributes are applied, the platform dynamically applies all of the relevant templates to the devices. And by taking a layered approach to this, you can have multiple templates applying increasingly detailed configuration to the devices that you're trying to monitor. So this ensures that all of the different settings that you need applied to the new device are applied without manual intervention. So for example, if a new BGP router comes online, it should not only get all of the basic vendor specific settings you want, like bandwidth, CPU, and memory, but it should also get BGP specific monitors like peer status and route table size, and make sure the network team is on the list of people to get alerted whenever there's a problem with it. You can also do things like predefined log messages to look for and report on, set all the performance metrics that you want to watch and what those thresholds and alarms should be. So this works for things like servers and their applications too, like SQL or Exchange or Active Directory, and even for cloud-hosted resources like Elastic Load Balancers or cloud-hosted database instances like RDS. You can use these templates to define authentication, escalation, and even those automated response actions. So it's designed to be really flexible, so it can meet the needs of a global enterprise-sized customer, but still be simple enough that a small IT department can use it without a ton of training or without any dedicated personnel. And by applying these templates at different levels, we can make changes safer and eliminate blind spots in our monitoring. So the idea is if I've got a global Windows template that applies all my basic Windows settings, but then I've got a more specific template for my SQL servers that does things like add SQL specific monitoring and turns up the CPU settings so I don't get as many alarms on the CPU because those guys run hot. I can still make global changes to the way I'm monitoring all of my different Windows systems by changing that global template, but it will never overwrite more specific application settings. And that makes making large scale changes safer. So our automation architecture around this has a lot of different moving parts and it looks complicated, but it's actually pretty simple. So let me walk you through it. It starts with that discovery that we talked about, which is driven by linking to the APIs or CMDBs, cloud providers, SD-WAN providers to find new devices to monitor. Also, of course, includes scanning. So we're looking about connected network segments, finding new segments to scan, finding new devices to monitor, and doing that in a non-intrusive way that doesn't add a lot of load to the network or to the systems. And of course, those inbound APIs that allow process integration. So if you've got things like a homegrown inventory tool, for example, or automated provisioning tools like Ansible, it's really easy to link those into the process to make sure that the first thing that happens is that monitoring. Together, this is kind of what we call discovery automation, and new devices that are added this way are then passed off to the auto configuration process, which uses those rules we talked about to automatically do things like put devices into all of the right categories, put them in all the right dashboards and applications and site groupings, and then using those criteria to drive the automated reporting. So as new devices are found, they're automatically put in the right dashboards, they're automatically added to the right reports. Those organizational units then also drive those templates. So we can control what templates are set with the device, and those templates apply all of the different settings that we want. So without having to maintain hundreds of different templates, we can make sure that we're layering the right ones together, and that drives authentication, alerting, anomaly detection, automated response actions, and more. And these settings get applied to new devices, configures the monitoring engine, and that drives all of those different dashboards and outbound notifications for things like alerts via SMS or email or application push, as well as things like ticketing integrations with ITSM systems. So now that we've automated the process of getting new monitoring provisioned, the next level of automating monitoring includes automating the response to events. And this allows you to take appropriate actions in the event of a failure or even an unusual condition like an anomaly by automatically executing commands on devices or sending API calls to applications or cloud providers. So the idea is to link in things like CLI commands via SSH or PowerShell, or use APIs like webhooks. So you can do things like restart processes, deploy new containers, retest applications, or even just dump real-time diagnostics. So as soon as a problem is discovered, you've got the log information you need to fix it in response to that incident. And some folks are, as I mentioned, going to be uncomfortable with automatically executing commands. So you can build in that manual check step if you need to, or if you prefer to do it that way. So if you want to have that click to reboot button directly into the web interface of the monitoring system, but limit that access to just administrators, we give you a really easy way to do that. However, keep in mind that when you get to this level in your automating response, things like maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade is not going to go like you expect because the monitoring system is going to start taking action in the background. And nothing's more frustrating than pausing an application service for a deployment and having the server suddenly reboot. Well, we make that process as easy as possible though, because you can create maintenance windows via the web interface or even via an API, so you can tie it directly into your change control system. Now, incident management is another key part of automating the incident response. And this is how we refer to the process that allows our platform to understand complex or advanced dependencies with the goal of reaching zero false alarms. And these allow you to easily override configured actions in order to do things like send customized alerts or suppress redundant alarms or automate specific responses like running that PowerShell or SSH command or calling a cloud API to scale resources up. One good example of how this might get used is we had a customer who had a lot of remote retail locations and they had very limited bandwidth. But they were monitoring it, and once they detected that the site was getting congested, they'd suggest a circuit upgrade and they'd schedule that with the provider. But the telcos take 30 to 45 days to deliver those upgrades. So they entered an incident management rule that would intercept any bandwidth or latency alarms for that site and send a message to the branch manager and let them know, we know about the problem, the upgrade's already been ordered, you don't have to call the help desk about this, it's already being worked on, and here's the estimated install date. And that managed to reduce the inbound calls into the NOC by 80% for those kinds of incidents. So you can use it for those kind of functionalities, or even if you're just getting an alarm for low free disk space on a server, you can automate the process of clearing out the cache and temp files or rotating the logs before the NOC even has to get involved. You can also configure dependencies based on groupings. So for example, if you're seeing a bandwidth issue on a location, you can combine any latency alerts happening at that location into the same incident. So we can reduce the amount of alarms coming out of the system. Or if you're running a cluster of systems, you might want to take different actions or send different notifications depending on the state of other cluster members at the time that that event occurs. To really take advantage of automated response, we also want to make sure we're removing false alarms as well as finding hidden issues. And detecting unusual behavior instead of just relying on static alarm settings is a key way to make this work. So in our platform, you can use anomaly detection to find changes in application behavior, for example, and you can apply it almost anywhere. So CPU, memory usage, running processes, even the volume of inbound log messages. Because if, for example, the application goes from 10 login failures an hour to 1,000, maybe that last deployment didn't go as smoothly as we thought, but now we know exactly where to start working on that problem. We can automatically build a baseline behavior model using the large volume of historical data we retain, which is 3 years for most metrics. We automatically adapt that baseline as the environment dynamically changes and evolves, so that these anomalies can be detected based on changes in baseline behavior, looking at patterns like time of day or day of week or even hour by hour. And this allows you to find unexpected impacts. So for example, one customer got notified when the number of transactions on their database dropped below the normal level for 9 a.m. on a Wednesday morning. And they were able to quickly trace that to a UI change that was routing orders to a dev system instead of the production one. But that sort of anomaly would never normally trigger a static threshold. But it was quickly identified and able to open a trouble ticket for them before they really experienced a serious impact in sales or operations using that anomaly pattern recognition. So how that ties in is into the existing automation architecture. We've looked at this diagram just a minute ago, so this should be familiar, but we talked about how autoconfig drives those attributes that assign the templates, and those templates control the parameters that are used by the monitoring engine. That monitoring configuration, though, also drives active response. So this is automating the response to incidents and taking the load off the NOC or operators by automating well-established resolutions, which can reduce MTTR, or if we choose, we can let the operators take the final action, but point them to a click to reboot button so they know exactly how to do it and execute remote commands or call APIs to restart virtual servers or launch new containers without having to train them on exactly the processes needed to do that, or even grab those real-time diagnostics. So if we're dealing with an intermittent problem, we can make sure that as soon as the problem's detected, I've already dumped the logs. We don't have to wait for a human response there. Now, the next level here is kind of encased in a bit of a hype cloud because everybody wants to talk about AI ops. So a lot of the talk around AI ops is usually heavily coded in marketing speak. So I want to take just a second and tell you about what our approach is here, because our approach to AI ops mirrors our approach to all IT management. The first and most important thing is that the technology be usable. So systems that require weeks of specialized training to take full advantage of aren't really a good solution in our opinion. And it needs to be able to offer value to all of the different IT teams quickly and easily. But it also needs to be practical. So AI and machine learning are only as good as the data they have to analyze. And we've spent 20 years collecting baseline data and experience in thousands of different customer environments. So this has allowed us to build solutions based on a strong foundation of practical and pragmatic customer use cases. Finally, the AI functionality should be integrated. So our approach is to take what's called a domain-centric view of the environment, which means since we already have a deep understanding of the type and context of data that we're collecting, it gives us a huge head start in interpreting and processing that data to make meaningful conclusions and take meaningful, effective actions based on it. That means you don't need multiple overlay products to try to get that benefit, and you skip all that integration work and extra administration. So even after automating the process of finding new things to monitor and then automating the process of setting all that monitoring up and then automating the process of responding to those, we still have the task of regularly reviewing what's going on in the environment, tuning to reduce false alarms, optimizing monitoring configurations, making sure everything's instrumented. So in order to get to this fourth stage of automation maturity, we're going to have to leverage the power of AI and machine learning to help us keep everything running and monitored. So the first phase of this for us is an automatic administration tool we call AI Autopilot, where we're using artificial intelligence tools to evaluate how the monitoring system itself is configured, including things like what performance metrics and thresholds we're using, how it's interacting with devices in the environment, and analyzing how those are performing, looking at all the reports for us in essence, so that it can automatically identify common configuration issues or integration problems. For example, finding systems where the authentication credentials were changed and the monitoring system wasn't updated. So it can find the correct ones and automatically apply them so we're not missing any performance data or alerts. Or look for things like what are other customers doing in similar environments and develop best practice recommendations to point out things that might be configured unusually or where a more optimized way to monitor something exists. And then it can provide recommendations where an administrator can apply them with a click or even deploy those changes fully autonomously if you wanted to try to make the system fully self-healing and make it self-tuning. So once this is implemented, it's a fully automated process. It's just a matter of switching it on and then deciding, which changes you want it to ask for approval for and which ones you're going to empower it to make autonomously. And using this technology, we've seen existing customers of ours reduce their alert volume by a further 77% and cut their admin time by a third. So it's got a practical application for sure. And let me illustrate how this fits into that automation architecture diagram that we've been looking at. So once it's switched on, what Autopilot's going to do is it's going to look at all of the different system element configurations and look for things that can be optimized, things that are, thresholds generating too many alerts, things that might be misconfigured or not integrated properly, where maybe we're getting DNS failures or mail is bouncing, or other problems like that, things that are configured in a way that's contrary to best practices. And then it can provide reports and recommendations, including a manual approval process, or it can automatically apply those changes directly to the various configurations within the platform. And this effectively reduces the training and administration load, makes the software self-tuning and self-healing, and ensures that the tool stays optimally configured for your environment with a minimal time investment. So the recommendations and best practices are continually updated from the cloud, if your system is connected, to make sure that as customers find new and more efficient ways to do things or the industry standards change, your platform continually stay up to date. And if you're running in a standalone or an isolated mode, you can also have those Autopilot updates installed with the regular software upgrades. So as you're applying patches to the system, it's learning new models, it's getting optimization for the existing models, and then it's constantly learning and adapting to your data as well. Now with that, I'm going to turn it back over to Kyle for just a minute to give you a brief introduction to who Netreo is as a company for those of you who haven't worked with us before. Kyle?
Awesome. Thank you, James. So just a quick reminder to our audience today, feel free to start asking any of those questions you may have. We will open up the floor in just a little bit for that live Q&A. So James, if you wouldn't mind going back on that slide. James, yeah. So for those of you who don't know Netreo, we've been in the business of IT infrastructure monitoring and management for over 20 years now. And just recently with our acquisition of Stackify, we now have over 1,400 customers in over 60 countries. We play very well in the highly regulated organizations such as finance, aerospace, transportation, organizations who need high reliability and scalability like healthcare and life sciences, and also organizations with real-time needs like emergency services, as well as marketing and advertising. So we're monitoring the systems that help do everything from launch rockets to outer space to saving lives. If you get a chance, I suggest everyone go take a look at our reviews on G2 Crowd. We are regularly recognized as one of the easiest tools to use, easiest admin, easiest setup, and of course, the best support in the industry. We love taking care of our customers and partnering with you. So with that, I'm going to go ahead and open up the floor for questions. And while I do, I'm also going to launch a quick poll here. So please let us know how we can help you further. This is an optional poll. If you don't have any needs for follow-up from us, no need to fill it out, but we'd love to show you a technical demo of the Netreo platform, introduce you to our ASAP or swap out programs. So for those who don't know, our ASAP and swap out programs. So ASAP is our accelerated SolarWinds alternative program. So if you're having any frustrations or issues in relation to the recent SolarWinds breach, we're happy to help you out there. We've got a quick jumpstart program to get you up and back to monitoring quickly. And we'll also match the price of your existing annual subscription or maintenance cost. And then we're also, if you're interested in a technical demo of Netreo, we're happy to get that set up for you. We're actually offering $50 Amazon gift cards for any qualified demos of the Netreo solution. So feel free to reach out to us there or fill out the poll and we'll get you followed up with. So as far as questions go here, not seeing a whole lot. So James, I know we've had, and you touched on this a little bit, but can you explain a little bit more about how Netreo's automation helps to essentially give customers zero-touch onboarding?
Sure. So part of the automation architecture is designed to really kind of eliminate the admin portion of bringing devices on board. So by linking that discovery process directly into rules that are established specifically for your environment, as far as how you want to monitor specific applications and who should get notified about them, what kind of reports and dashboards and organizational units you want to create, you can really automate the process. So as a new device is brought up in AWS, for example, it can be automatically detected. We'll detect that it's running, for example, a SQL database. We'll add it into all of the different dashboards that are relevant to the database categories and the applications that rely on those settings. And then from that, it drives those templates, and the templates can be applied at multiple levels. So as I said, you can have that default Windows template that controls all the basic stuff, but then extend it with application specific settings. So as it detects, hey, this is a SQL system, now it's going to go in and automatically add in all the SQL specific monitoring and all the SQL alerts, so we can make sure the right teams are getting notified, and then take that, all of that information, and layer it onto the device in a way that makes sure that it's not only monitored, but it's monitored correctly and completely without any manual intervention. And a lot of our customers have gotten to the point where when they bring new systems on board, they don't even have to log into the monitoring platform. The automation just makes sure everything gets configured for them, and then it gets added into all of their automated reports and all of the dashboards that their operations team and that their server teams and application teams are using to keep an eye on the environment. So the whole goal of that architecture is really to try to minimize the number and amount of people that are required to keep the system up and running, and to keep everything monitored so that you don't run into situations where this team brought a whole bunch of new servers on board, but they got sloppy with bringing them into the monitoring platform. So maybe there's up-down monitoring on the systems, but none of the applications are being watched correctly, or the database on that system fails, but the database team never gets notified. Instead, the application team has to find it with a completely different tool, and try to eliminate all of those kind of overlaps and blind spots, so that when there is a problem, it can get routed to the correct team quickly and efficiently, and not have to send out mass notifications where you end up with 4 different groups of people all trying to troubleshoot the same problem simultaneously and wasting a lot of time and effort.
Awesome. Thanks, James. So it looks like we have a question from Prashant in the audience here today. So the question is, can Netreo monitor on-premises resources or services hosted on the cloud? So meaning Azure or Amazon?
Yeah, the platform itself is designed so that it can be deployed on-premise, or it can be deployed as a cloud-hosted system. And either of those platforms can monitor both on-premise and cloud resources. So it's really optimized for hybrid environments, because most of what we're finding is a lot of our customers are moving to the cloud, but they haven't completed that transition yet, or they've got some resources in the cloud and some resources on-premise that are doing different functions, but they really want a unified platform to monitor all of that. We can do that either from the on-premise solution, where all the data is kept on-premise, which is very popular with our higher security and highly regulated customers like healthcare, for example, or finance, or it can be entirely cloud hosted, where your interaction is all through the web portal, and then the data is collected both directly from the cloud as well as from on-premise systems and rolled up all into the same dashboards.
Thanks, James. Great question. So one last question that I have here for you, James, is beyond some of the examples that you discussed throughout the content, are there any unique ways that our customers are using Netreo for automation that you can think of?
Well, I think every customer environment is a little bit unique, and they've got kind of their own way of doing things. And there's a lot of similarities between them, but everybody's got a very slightly different approach to how they want to integrate automation into the environment. We have a lot of customers using it to automate things like configuration pushes out to all of their network and infrastructure devices, for example. But some of them are using it for kind of innovative use cases. Like we've got some government customers who are using it to do things like monitor the vaccine refrigerators that are storing their COVID-19 vaccines, to make sure that they can get alerted if there's a temperature problem with any of the remote storage devices, and automating the response to that by sending out messages to let the folks on premise know that they need to go address that, or move the doses to different refrigerators, things like that.
Awesome. Thanks for that, James. All right. So I haven't seen any other questions come in here, but for our audience, in just a bit here, everybody will receive a copy of the recording of this webinar. So feel free to share with your colleagues, friends, family, anybody who might be interested. And for those of you who did request follow-up, our team will be getting back to you hopefully this afternoon, if not within the next 24 hours. So with that, James, thanks so much for the great content. Happy to have you on as always. And thank you to our audience again for attending today. We look forward to seeing you again on a webinar soon.
Thanks, everyone, and have a great day.